going to go ahead and revisit the change of base rule. I know we talked briefly about this in one of my other videos, but the change of base rule says that if you have a logarithm of some base of something, you can actually change the base of that logarithm to anything you want, and that will become the quotient of two logarithms of that new base. So log base b of m can become log base c of m divided by log base c of b. The m and the b are coming right from the previous logarithm, and the c, the new base that you're changing it to, can become anything you want. In the following couple examples, I'm going to show you how to change something to common bases and how that might be useful. I'm also going to show you how to change something to the base 10, which is the common logarithm, so that it can be easily evaluated in the calculator. There's a couple different ways you can do some of these problems. Okay, so here we have an example. We have log base 81 of 27. I want to try to evaluate that. I can change the base to anything I want. One thing that I notice looking at the numbers there, the 81 and the 27, is that those numbers can both be written as 3 to a power. 27 is 3 to the third power, and 81 is actually 3 to the fourth power. If I can make that realization right there, it might not be a bad idea to go ahead and change this to base 3 logarithms. Now I'll talk about a little bit more about why here in a second. So the change of base rule says I can change the base to anything I want. I just said I'm going to try to change it to base 3. So this would become log base 3 of 27 over log base 3 of 81. Again, remember, the base goes on the bottom, just like the basement of my house, the base of an object. If you are a musical person, the bass is your lower sounds. That might, I said, I kind of make that reference to help students remember that. But now I have this written using the change of base rule, and I can actually go ahead now and rewrite the 27 as the 3 cubed I talked about a second ago. So this will become log base 3 of 3 cubed over log base 3 of, and we said 81 could be written as 3 to the fourth. Now, here's the cool thing. If you remember back from the previous videos, the base 3 logarithm and the base 3 exponential are inverses of one another, and therefore would kind of undo or cancel one another out. So here I have the base 3 logarithm of this base 3 exponential. So this part right here, in a sense, would just cancel itself out. The log base 3 of this base 3 exponential, and just leave you with this 3 in the numerator. Same thing on the bottom. This log base 3 of this base 3 exponential, that part right there, the base 3 logarithm of 3, would just cancel itself out in a sense. Or you could think of it as if you move the 4 down in front of it to make it 4 times log base 3 of 3. Log base 3 of 3 is actually 1 with that. So it would become 4 times 1 with that. So you get your 3 fourths right there, which as a decimal would be 0.75, like that. Again, converting to base 3 logarithms, because we recognize that both numbers involved could be written as base 3 exponentials, and then we can go ahead and simplify based on the fact that the base 3 logarithm and the base 3 exponential are in fact inverses of one another. Okay, if I didn't want to take that approach where I changed the base to the common base, I didn't want to worry about that. I could just go ahead and change these to a base that would be easy to evaluate in my calculator. That would be the common log base 10. So if I chose that route, this would become log of 27 divided by log of 81. And at that point, I would go to my calculator to evaluate that. Since the common log is the button on the calculator, I can just type that in and quickly have my answer. And I already know what I'm going to get. I'm going to get 0.75 for that. I already showed you in a previous video how to evaluate that in the calculator, so I'm not going to go ahead and do that again. Now, not all problems can even be written with the same base like that. So here's an example of a problem where doing what I did in the first part of this video wouldn't really be helpful. I can't write 5 and 36 with the same base, so that approach isn't going to help me here. So this is one where I would just want to go to common logarithms and just convert this to the common log of 36 divided by the common log of 5. And at that point, I would want to go to my calculator and just compute log of 36 divided by log of 5 and round to whatever amount of decimal places the direction specified. I think this is approximately 2.23 if I remember right. Again, I'm not going to show how to put that in the calculator in this video. I've already done that in a previous video. If you have questions, let me know.